So, welcome you all into today's LeetCode challenge. This is our day 290, and today's LeetCode question is question number 2658, maximum number of fishes in a crate. The question states that we have given a matrix, 2D matrix crate of size m cross n, where every r, c represent its cells. A cell is a length cell if it is if it is equals to 0, or if it is greater than equals to 0, then that shell is a water cell containing value that the number of fishes is present in it. A fisher can start its movement from any cell and move until there are adjacent water cell next to that cell and catch all the fishes that are present at those cells. We have to return the maximum number of fishes that the fisher can catch optimally, and the fisher can move into all four directions at any water cell. Let us take the example number 1. The example number given to us is this: 0, 0 contains 0, that means this is a land cell, and 0, 1 cell contains 2. This means this is a water cell and the number of fishes present in this cell is 2. The number of fish present at this cell is 1. This is a land cell, land cell, land cell. Number of fishes in this cell is 4, and that's all. The dimensions for this is 4, 4, as you can see. So we first initialize a 2D matrix, a 2D Boolean matrix for this, and maintained each cell with false, that means named visited. That means now firstly those cells are not visited yet. The technique to solve this problem could be DFS or BFS, whatever we want, but I thought that BFS technique is easy to understand rather than DFS. So we will solve this using BFS. To solve this problem, we first found out what are the dimensions for the given grid. This n represent the number of rows, and this m represent the number of columns. Now just initialize a 2D vector of Boolean type named visited, which is first initialized by false at every cell, like this. Now maintain a variable called max fishes. Initialize that with 0. That means first the maximum fishes the fisher can catch is equals to 0. Now the simple approach for this problem is we can start our journey from I equals to 0, 0 and move until the matrix ends or all the cells of matrix could be covered. If we found out any cell which is a water cell, so we start our journey from that cell and move. The fisher can move until there are water cell adjacent to this initial cell, and moving in the journey, the fisher can mark those cells as visited. This means that those cells are previously visited by the fisher. So We start our journey from this j equals to 0, j comma less than equals to m, and we have to check if that grid of I comma j is a water cell. That means it is not equal to 0. It is always a positive value greater than equals to 0. And we also have to check that this cell is not previously visited by any other fishing movement. Now we have to mark our maximum number of fishes, or we have to update our maximum number of fishes we can catch from this initial movement. Let us initialize a function called BFS, which is a movement for fisher. The fisher can start its movement from any of the water cell and move until there are adjacent water cell. Let us name that movement called BFS. Pass the parameters required for the movement. The required parameter for movement is obviously the grid and the current nodes at which the fisher are, and the visited array to keep the previously visited cells. Now finally we will return our max fishes. What are the maximum number of fishes? Since the fisher can move into 4 directions, so we have to maintain our direction ratio vector as well, that is TIRs, like this. -1 comma 0 and this. Let us visualize this, what this -1 comma 0 means. Let us suppose we are initially at this r comma c. If we want to move upward to next upward cell next to this r comma c, then what are the coordinates for this? We are in the same column, so c is maintained as c, but the row is decremented by 1. That means the coordinates for the just above cell for r comma c should be r minus 1 comma c, and the coordinates for the just right cell of r comma c should be r comma c plus 1. That means we are in the same row, but the column now is incremented by 1. As of down, the row is incremented by 1, but the column is same. And for the left movement, the row is same, but this time the column is decremented by -1. So this -1 comma 0 represent this upward movement, that means the up, and this 0 comma 1 movement represent this 0 comma 1 means the right movement. This 1 comma 0 represent the down, and 0 comma 1 represent the left movement, like this. Now we have to initialize our BFS, or define our BFS function. What this BFS will actually do: pass all the required parameter for this function, like this. Now every time we encounter this BFS function, that means we are starting our new journey. As we are starting our new journey each time, then we have to maintain a temporary variable that is initialized with 0, and this temporary variable will now incremented as per the values present in those water cells which are encountered in this journey. Now we also have to maintain a QE that takes as a pair of int in its like this. This QE will store a pair of r comma c or row comma column like this. Now first we have to mark our current row call as visited. That means the current water cell is first have to mark that this is visited now, and push that row comma call into the queue. This queue basically intakes all those water cells only. This queue intakes only water cells and nothing else. Now move on queue until this queue gets empty. Find out the current r comma c in queue. Pop up that pair in queue, and now add our current r comma c value into the fishes. That means if we start our journey from this column, so we will add 2 to our fishes. We can catch up to on this cell, and now for every cell we have to move into 4 directions. Using dirs we can move. The new coordinates will be row is updated as like this and column is updated like this. Now we have to check whether those new rows and new column coordinates are valid or not. That means these new row and new column should be in the range of matrix like this, and these new row and new column are were not previously visited. These should not be previously visited, and these new row and new column should be a water cell and not a land cell. Mark them as visited now and push them into the QE, and now return our temporary fish variable like this. Now let us run this and check if there is any mistake in this. I forgot to add a C. Yeah, it is running fine. Let us submit this. Yes, it is running fine. And now, let's try run our code again. For the above example, what are we doing? These are the dimensions, and we maintain a Boolean array for I equals to 0 and j equals to 0. This is initialized like this. I equals to 0 will point I equals to 0 will point like this, and every time j equals to 0 is now pointing to this. Now this will check if grid of I comma j is greater than equals to 0 or not, greater than 0 or not. This is 0, so the condition gets false, and j is incremented by 1 now. J is incremented by 1, so j will now points to this, and this is a water cell, so the condition is true. Grid of I comma j is greater than 0, and this is not previously visited as well. Here we can see that this is not previously visited. So we will move into the inner loop where we update our max species, and the current dimensions are passed into this function pfs. So here we initialize our QE, and first we mark our row comma call as true. So this is now marked to true. This is now marked as true like this, and these coordinates are pushed into the QE as well. So let us maintain a QE. Let us suppose this is a QE which takes coordinates 0 comma 1 as coordinate is passed into this. So the QE will take a pair like this 0 comma 1, and we will check now whether the queue is empty or not. The queue is not empty yet, so we will find out what are the r comma c in queues. QE dot front is pointing to this 0 comma 1, and the current row is this 0. That means this is r and this is c to us, like this. We will pop out this from QE. So now we are popping out this, so like this the QE is, and we will add the current value at r comma c in fish. So the fish will now contain as 2. Fish will contain the grid 0 comma 1. What is 0 comma 1? Grid of 0 comma 1 is 2, so now the fish will contain 2. Moving forward, we are moving into 4 directions for r 0 comma 1. So the 4 directions for 0 comma 1 should be this: up, left, down, and right. The condition for moving in each direction should be that these are greater than equals to 0 and less than equals to number of rows. NC should be greater than equals to 0 and should be less than equals to M, and that node should not be previously visited, and that node is also not a land cell. So moving in up, we cannot move up, we cannot move left, we cannot move down as well, but we can move to its right cell. The condition is true for this. These four conditions are true only for this 0 comma 2. So now this 0 comma 2 is marked as first visited like this, and this 0 comma 2 is now get pushed into QE like this. The front part is of QE is now this, and R comma C will now points to these coordinates. This is R and this is C. Again the loop is while loop will check whether Q is empty or not. No, the Q is still not empty, and R comma C will now point to 0 comma 2, and fish will incremented by grid of R comma C. So what is the value of grid R comma C means this is 1, so now fish is incremented as 2 plus 1, that is 3, and these coordinates now gets pop out from QE. And for this one we will check our up, left, down and right movements. We cannot move up, we cannot move right, we cannot move left, and we also cannot move left because this 0 comma 1 is previously visited. So this function get ends and will return 3 as the maximum number of fishes if we start from this. And like this our next journey will start from this 4, and this will catch at max as 5 fishes, and the next journey will start from this 3, and this will catch at most 7 fishes, and the final journey in this question will start from this coordinate, and this will catch as max to 5 fishes. So looking up all those journeys, the maximum number of fishes we can catch up to is the 7. So this could be the answer for this. I hope you will found this description or this solution easy, and I hope this question is now easily takeable to you all. And thank you so much guys for today's LeetCode challenge. See you in the next challenge.